welcome to this session, the divisibility rules of numbers. So this is a one part of the number theory. The various sessions are there, and this is a one session where we are learning how to check whether a number is divisible by some other numbers or not. Right. So suppose I give you say some number, maybe of say 3, 4, 5, 6 digit, and I will ask you how will you check whether this number is divisible by maybe say 2 or maybe a 3, maybe 7. So there are some rules by which we can identify whether the numbers are divisible or not. And this will be very helpful when we are talking about that, okay, just check by the option. So when you're checking with the options, so sometimes there are possibilities that by checking the divisibility rules, we can eliminate the wrong options, right? So this is the one method where we can speed up the calculation part or where we can eliminate the given option. And then we are having a good chances of getting the correct answers, right? So, okay, learn this what are the divisibility rule of different numbers. And to the end, we will be solving some questions based on the divisibility rules, right? So welcome to all of you. And yes, let's start. Let's begin with the session right now. So first, let's start with a very simple number, which is 2, right? Now, when we're talking about the divisibility rule of 2, so take any number, and if the number is ending with the digits like 0, 2, 4, 6, or 8, then I can say the number is divisible by 2, right? Now, if I ask you, how will you check with the divisibility of 4, maybe the divisibility of 8, maybe the 16, and so on, right? So, what is there when you're checking about all these things, right? So, now if I say for 2, right? 2 is what? 2 raised power 1. What is 4? 2 is square, right? What is 8? 2 cube. What is 16? 2 raised power 4. What is 32? 2 raised power 5. And so on, right? So when we are having some numbers which are the powers of 2, right? Just like I'm taking example 2, 4, 8, 16, 32, 64, and so on, right? So whatever the power of 2 is there in the number, those many last digits should be divisible. So for 2, what is the last one digit? For 4, last two digit. Because in 4, what is the power of 2? 2, right? From 8, what is the power? 3. So last 3 digit should be divisible. For 16, last 4 digit should be divisible. For 32, last 5 digits should be divisible. And this way we are checking that whether the number is divisible by 2, 4, 8, 16, etc. or not. So see this, the last statement here. Now, if you're checking the divisibility, right? So for 2 raised power n, the last n number of digits should be divisible by 2 raised power n, right? So this is a rule for the 2 or the powers of 2, right? Now, moving further for the next rule, which is for the 3. So if I talk about for the 3, now the rule for the 3 or the power of the 3, right? So this is what? That is sum of the digits should be divisible. Suppose if I say 1, 2, 3, 4, 5, 6, 7, 8, 9. You want to check whether this number is divisible by maybe 3, maybe 9, maybe 27, or some power of 81, right? Or some power of 3. So what to check? Just add all the digits. So when you're adding the digit, this is coming out to be how much? 45, right? Now, this is what? Sum of the digit of the number. Now, I can say 45 is divisible by 3. So, this number is completely divisible by 3. But if I check for the 9, right? So, this is also divisible by 9. So, I can say this is also divisible by 9 also, right? Now, if I check about 27, right? So 27 is not dividing 45. So this number is not dividing by 45 or maybe 81 etc. Right? So what is the rule for the 3 or the powers of the 3? That is sum of the digits should be divisible by 3 or 9 or 27 or 81 or 243 etc. Right? So these are the rule for 2, 4, 8, 16, 32. That is power of 2. Rules for 3, that is sum of the digit, right? For 3, 9, 27, 81, 243, etc. Right? Now, coming for the next, that is 5. So the rule for the 5 is same as the rule for the 2. Right? So if I check for the 5, what is the 5 raised to power 1? For 25, what is the 5 square? For 125, what is there? This is 5u, right? 625, what is there? It is 5 raised to power 4, and so on, right? So, if you are checking for the 5, so what is the value? What is the answer? The power of 5 should be divisible. For 5, last one digit. For 25, last two digit. For 125, last three digit. For 625, last four digit, and so on. Right? So same rule as we are having the power of 2. Right? The same rule. So we are having now for the 2, 3, 4, 5. Right? Now, coming for the next number, this is what maybe a some composite number, right? Where you can break down the number into some different factors. Say, for example, 6, for example, 12, for example, 18, etc. So if I want to check for the 6, right? So 6 I can break into what? 2 into 3, right? If I want to check for the 12, so 12 can be broken down in what? 2 into 6 and what? 3 into 4, right? If I want to check for the 18, so 18 can be broken down in what? That is 2 into 9 and what? 3 into 6, right? So how to check where the number is broken down into a multiple factors, right? So how to check the divisibility rule of these numbers? So for 6, because we are having only one pair, so we are checking for this only. But when we are having for 12, so how to check? Now, whenever you are having a different pair for a one number, so always take the number where the highest common factor is 1. So in this, we are taking 3 and 4 for checking the divisibility of 12, not the, yes, this is not considered. 2 and 6 will not be considered. Similarly, when we are talking about 18, so we will take this part, that is 2 and 9, because highest count factor is 1, but we will not take the 3 and 6 because here the highest count factor is not 1, right? So whenever you have a sum number where you can divide the number, you can break down the number into multiple factors, right? Multiple pairs of factors, then always consider the pairs which are co-prime. And how to check the co-prime? Then the highest count factor should be 1, right? So always take the pairs where the highest count factor is 1, right? Now, so the next number, the 7, right? So for 7, how to check? What to check, right? So suppose if there is a some number, I just take some example of the number, right? So if there is a some number and this is say 2, 9, 4, 6, 8, 1, 3, 5, 4, 1, 6. Right? Something like this number. Now, what to do? Just start from your right hand side. Right? Start from your right hand side and and make a group. Make a group of 3 digits. One is this. One is this. One group is this. And one group is this. If you're not able to make a group of 3 digits, what to do? Add 0 in the beginning. Right? This is the reason what I am telling you that start from your right hand side. Because when you're adding a 0 in the beginning of the number, makes no change. But when you're adding a 1 0 towards the end of the number will become 10 times. Right? So now, when you're adding up all these, right? So just serial number them. This is a first group. This is the second group, right? This is the third group, and this will be the fourth group, right? So now there will be a sum groups at 1, 3, 5, 7. Suppose if the number is big, so the groups are coming at odd places. There will be a sum group which are at 2, 4, 6 at even places. So separate them. Even place group separately, odd place group separately, right? So one group here we are having is what? 0 to 9, right? And 1, 3, 5, right? Second group we are having what? That is 4, 6, 8 and 4, 1, 6. Right? Separate even place group, separate odd place groups. Now add them. So if you are adding them separately, right? Add them separately. So this is the even place group. So this is 9 plus 5, 14. 4 is here. 1 is carry. 3 plus 3, 6. Right? And this is 1. This is 164. Okay. The second, the odd place group, 8 plus 6 is again 14, right? 1 is carry, and this is 6 plus 1, 7 plus 1, 8, and 4 plus 4 is 8. Right? So now we are having a two addition. One is for the even place group, and other is for the odd place group. Now, what is the next system? Now take the difference of these two additions, right? So this is 8, 8, 4 and 1, 6, 4. So this is 4 minus 4, 0. This is what? Taking a difference. Right? 8 minus 6, 2 and 8 minus 1, 7. Then now you are having a this difference 7. Then now what to do? Check whether this difference is divisible by 7 or not. So in this particular example, we are having a difference of 720. Right? Now check whether this 720 is divisible by 7 or not. Right? So if I check that 720 is divisible by 7 or not, so this is not divisible. Right? Now suppose when you're checking this difference and you're getting a sum difference which is maybe a 0, a 7, maybe a 14, maybe a 21, maybe a 28, or a sum number which is a multiple of 7, right? Then I can say this complete number is divisible by 7, right? But now, right now we are having a difference as 720, and 720 is not divisible by 7. So this means this complete number is not divisible by 7, right? So this is the method of the divisibility of number 7, right? What to do? Make a group of 3 digits from your right hand side, right? Separate the even place digits, separate the odd place groups, right? First, take the addition, the summation of these groups. Then when you're getting a two summation, take the difference and check whether the difference is divisible by 7 or not. If this is divisible, number is divisible. And if the difference is not divisible, the number is not divisible by 7. Right? Okay. Now, moving further. Number 11. Right? So almost the rule is same for the 11, but there is just one simple difference from the rule of 7. And what is this? Suppose take an example. You are having a sum number, say 2, 9, 4, 1, 6, 5, 7, 8, 4, 3. Right? You want to check whether this number is divisible by 11 or not. So in the 7, what we are doing? We are making a group of 3 digits, right? Here for the 11, what to do? Just separate the individual alternate digits, right? So if I separate the individual alternate digit, so this will be 2, 9, right? 4, 1. This is 6, 5, 7, 8, right? This is 4, 3. Done. So what you have done, you have separated individual alternate digits. And the next step is what? Just add them separately, right? This way, add them. And when you're adding, so you will be getting a two different sums of the alternate digits, right? So first one is what? 2 plus 4, 6. 6 plus 6, 12, right? 12 plus 7, 19. And 19 plus 4 is what? 23. So this is coming out to be 23. Done. So this is the first summation we are getting. Second, 9 plus 1, 10. 10 plus 5, 15. 15 plus 8, 23. 23 plus 3, 26. So this is coming out to be 26. So second summation is 26. Now, the next step is what? Take the difference of these two summations. So 23 and 26. Not the sign, right? Negative or positive. Just take the numeric difference. And the numeric difference is coming out to be what? 3. Right? The same thing here. Again, we have to check if you are getting a some difference which is maybe a say 11 or 0 or 11 or 22 or 33 or a sum number which is a multiple of 11, then this complete number is divisible by 11, right? Right now we are getting a difference as 3. So 3 is not divisible by 11. This means that this complete number is not divisible by 11, right? So for the 7, right, the rule is what? When you are making a sum number, starting from right side, take a group of 3 digit, right? Separate the groups which are even placed or which are odd placed, right? Take a individual summation, addition, then the difference. If the difference is divisible by 7, number will be divisible by 7. If the difference is not divisible by 7, the number will not be divisible by 7. And for the 11, we are not making the groups, we are taking the individual alternate digits. Then rest everything is same as 7. So add individual digits, get a two different sums, right? Take the difference. If the difference is divisible by 11, number will be divisible by 11. Otherwise, number will not be divisible by 11, right? And the next number which we are having is the number 13, right? So number 13 is having the same rule, right? Same rule as we are having for number 7, right? Same, exact, everything is same, right? In the our example, right? The last difference which we are having is what? 722. This difference we are getting, right? 722. Now, is this 722 divisible by 13? Yes, what do you say? Yes, everyone, just give me some answer. Is 722 divisible by 13? Absolutely correct, right? So 722 is not divisible by 13. So this means this number is not divisible by 13, right? Now, if you are getting a sum difference, maybe a 0, maybe a 13, maybe a 26, maybe a 39, or what? Some number which is a multiple of 13, right? Then this complete number will be divisible by 13. So same rule, no change, nothing. Just in the last step, when you're checking the divisibility of 7, now here you will be checking the divisibility of 13, right? And if you are getting a last step, the difference as a multiple of 13, number will be divisible by 13. Otherwise, the number is not divisible by 30, right? So these are the some different rules where we are having some different numbers, right? So the rules are for 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is what? Last digit should be 0, 11, 12, 13, right? So all these rules are there. So now just start and get us some feel, some calculation part for this, some application part of this. How do we apply all these rules in solving the different questions, right? So this file is there in the chat box, right? So you can just open up this file in your system also. And if you want to scroll up, if you want to scroll down, right? You can just do as per your requirement, right? And one information which is there that the advanced version classes of all these topics are there, and these classes are already started. So if you need some information what to do, just send a mail at support@edushastra.com and you will be getting a detailed information about the classes, the advanced level, advanced version of the classes of all these topics which we are doing here, right? So you can just send a mail at support@edushastra.com. Okay. Now, so this is saying the first question, what is the least perfect square divisible by 8, 9, and 10? So in this, what I need to check? I need to check a one number which should be perfectly divisible by all the three numbers 8, 9, and 10. Now, recall the rules. First number 8, what is the rule? Last three digits should be divisible. Okay. 9, what is the rule? Sum of the digit should be divisible. What is the 10? Last digit should be 0. And I need a one number, right, which is the multiple or the divisible by all these three numbers 8, 9, and 10. So now what should I do? I should or adopt a method that is the elimination of options, right? Which is a little quick and fast rather than checking a multiple and everything. So for 10, I know what is the rule. Last digit should be 0. So this way I can just cut this option, right? Because last digit is not 0. Okay. Now 9, what is the rule? Sum of the digits should be divisible. Done. So first number, first option, 4000. What is the sum of the digit? 4. And 4 is not divisible by 9. So I can cut this option, right? Second option, 64. What is the sum of the digit? 6 plus 4 plus 0 plus 0, that is 10. And 10 is not divisible by 9. So this is also out. Right. So my answer for this is what? That is the third option, 3600. Right. And this is what? A perfect square. Of which number? This is a perfect square of 60. Right. So this is the way I can apply my divisibility rule and I can check and solve the question quickly and fast, right? Okay. So I suppose you are getting the logic here, right? So now coming up the next one. Yes. So just go with this next one. That is a 4A56. This is a 4-digit number, right? Is a 4-digit number divisible by 33. So this is perfectly divisible by 33, right? The question is telling us that this is perfectly divisible by 33. What is the value of A? Okay. So quickly, everyone, just give me some answer and tell me out of the given option, what can be the possible answer, what can be the possible value for the A, right? Now, yes, just give me some answer, some value here. Yes, quickly, everyone. Everyone should participate in the session and you can just give your answer by typing the value, by typing the option in the chat box, right? So yes, now I am getting some responses, but I suggest to everyone, please participate and please solve the question, right? So when you solve yourself, you will be learning and you will be getting the understanding of the concept, right? Okay, so this is 4A56, the 4-digit number. I need to check the divisibility of 30. So 33, what to do first? This is a composite number, right? So 33, break this number into what? Factors. And this is 3 into 11, right? There are two factors for this. Now, I need to check first the divisibility of 3 and second the divisibility of 11. Done. So the rule for 3 is what? Sum of the digits should be divisible. For 11, the alternate digit addition and then the difference should be 0 or a multiple of what? 11. Then this is the way. Now, so I go with the options, right? Best ways, go with the option. So if I add the digits of this number, 4 plus A plus 5 plus 6, right? These are the 4 digits and I am adding them. Done. So this is what? That is 15 plus A. Yeah. And I need to check the divisibility of 3. So I have a some option A, B, C, D. Now you can say if 15 is divisible by 3. But see, if the 15 is divisible by 3, I should have A as 0. But option is not giving me this value, right? So I have to check a some multiple of 3 which is greater than 15. And what is this? If I make this as 15 plus A as what? 18. Next multiple after the 15. So if I take 18, so A should be what? 3, right? A should be 3. Now, if I take A3, I need to check the divisibility of 11, whether this is applicable or not. So just take the alternate digit difference. 4 plus 5, this is the one set, right? And if you consider A as 3, so 3 plus 6, right? This is the other set. 4 plus 5 is what? 9. 3 plus 6 is what? 9. Taking the difference of these, you are getting what? 0. So what is the rule for 11? If the difference is coming out to be a 0 or 11 or 22 or 33 or a sum multiple of 11, then the number is divisible by this, right? So now both the rules are applicable for the 3 as well as for the 11. So I can safely mark my option A here. That is A, the value of A is nothing but what? The value of A is 3, right? And if I put a 3, then this number is divisible by 33, right? Now, so I suppose now you are getting a good understanding of the divisibility rules, right? How do we check the divisibility rule for different numbers? How do we factorize the composite number? How can we check the individual numbers for checking the divisibility rules? Okay. Now, moving further. Okay, done. So just everyone quickly just attempt this. This is the sum of five distinct whole numbers, right? Whole numbers, positive numbers. And five, all are what? Distinct. You're done. So every time when you're reading the question, read the question very carefully. Missing a one small word may give you a wrong answer, right? So do not be in a hurry. Just read the question carefully and attend. Now this says if 60 is the smallest of them, so you have a five numbers and 60 is the smallest of them. What is the maximum value of the largest number can have? Right. So yes, quickly tell me. Just identify. You have a five different numbers, distinct whole numbers, and the sum is 337, and 60 is the smallest of them, these five. Then what is the maximum value of the largest number? Right. So now see this. Okay, just start solving. Okay, giving you 1 minute of time, right? Giving you 1 minute of time. Yes, yes. Give me some answers, some value. Okay. Yes, yes. Getting us some right answers, getting us some wrong answers there, but not to worry. Just here. They are saying five distinct whole numbers. So A, B, C, D, and E. Right? These are the five distinct whole numbers. This says the smallest number is 60. So I consider A as the smallest one and taking a value this is 60. Right? And this is saying five distinct whole number, right? And then what to do? I need to maximize the largest one, right? I need to maximize the largest one. So maximizing the largest one means minimizing the remaining, right? Remaining four numbers, and they all are distinct. So if I say this is 60, so next number should be 61 because distinct, right? And minimizing, and next number will be 62, right? And next number will be 64. Right? These are the smallest four distinct numbers. Right? And total sum is 337. So if I add these four numbers, right? So if I'm adding these four numbers, so yes, tell me what is the summation? What is the total addition you people are getting? Yes, quickly. Yes, yes, yes. Quickly, just tell me what is the total summation you people are getting. Okay, so this is 62. Okay, just make this 63, right? It's smallest. We are making this small. So this is 63, right? Yes. What is the summation you are getting? Yes. So yes, yes. Quickly, quickly give me. Yeah, absolutely correct. This is coming out to be 246, right? This is coming out to be 246. Done. Now I want to check the last number E. So if I check the last number E, what to do? I am subtracting the value, right, from this 337, right? This is my total summation of the five numbers. And subtracting the value that is 246, the summation of four numbers here. So when you subtract, so this is what? 7 minus 6 is 1, and 13 minus 4 is what? 9. Right? So the number you are getting is what? 91. The largest fifth number is what? Possible is option A. So largest number out of the given five number is what? That is 91. Done. So this way we are just minimizing the four numbers, maximizing the fifth number, and getting the value is 91. So my option A is the correct answer here, right? Okay. Now, just skipping this and taking a, yeah. So come to this. This is a positive number, little big number, right? X 6995538 y is divisible by 88, where x and y are single digit numbers, that is 0 to 9. Okay. What are the values of x and y respectively? Huh? So yes, quickly, everyone just give me some answers, some value. You have all the options here, right? Yes, yes, just try and type in your answer in the chat box. Yes, just try. Yes, absolutely correct for this. What we have to check the divisibility of 88. Right? And 88 can be broken down in what? 8 and 11. Done? So I need to check the divisibility of number 8 and the number 11. So what is the divisibility rule of 8? Last three digits should be divisible, right? And what is the rule for 11? Alternate digit summation and then the difference should be divisible, right? So for this number, when you're checking the divisibility of 8, so start with the last three digits, this, right? 8, 5, y. So you're taking 8, 5, y. Done? And you have the options, right? So when you're having the options, so you can start with the options. Best way, done. So if I consider the first option, so first value is for the x and second value is for the y. So taking a first option, right? What to do? I need to consider y as 6. Done. So y as 6, the number is becoming 8, 5, 6. And checking the divisibility rule of y. So when you're checking the divisibility rule of 8, so dividing this by 8, and I know this is perfectly divisible, right? This is perfectly divisible by 8. So I get this value for the y. Now if the y is 6, so x is what? 1. So taking x as 1 and checking for the divisibility of 11. So what to do? Separate the alternate digit. So just separate 1, 6, right? 9, 9. Done? 5, 5, right? This is 3, 8, 5, 6, right? This way you are separating, and what to do? Add them separately, right? Quickly add them. So you are getting a two different summations, right? Two different summations. First, 1 plus 9 is 10, 10 plus 5 is 15, 15 plus 5 is 18, 18 plus 5 is what? 23. This. The second, 6 plus 9 is 15, 15 plus 5 is 20, right? And 20 plus 8 is 28, and 28 plus 6, right? 28 plus 6 is what? Yes, that is 33. 28 plus 6 is, you are getting 34. No? And now check the difference. So when you're checking the difference is coming out to be 11, right? So if the difference is 11, so this number is perfectly divisible by 11 also. So I can safely mark my option here, that is option 1. X is coming out to be what? So my x is coming out to be 1 and y is coming out to be what? 6, right? So this way we are checking the divisibility rule of different numbers, maybe a 2, 3, 4, and so on. And for every number, there is a separate rule, there is a separate property, right? So just revise, recall all these property and try to solve the questions from the study material which you have, right? Which you are getting from the head office. So just use those books, those study material, and then practice a lot so that you have a clear understanding of the concept, right? So with this, we are winding up the session for today, right? And my suggestion to everyone, revise the concept. This PPT is there in the chat box. You can download this PPT, right? And then you can use this PPT for your practice purpose, for your revision purpose, and then give the test on the student portal so that you have a clear understanding and good understanding of the concept, right? So with this, I am winding up the session.